Today we are going to conclude our discussion initiated in our previous video on the comparison between WACC and APV. In the previous video, the assumptions behind WACC and APV were explained. These assumptions condition the practicality of either approach depending on the circumstances. In this opportunity, we are going to recommend under which circumstances WACC is the best method or APV is the best method. The choice of method depends on the most appropriate way to discount the tax shield. Let's focus on this table. We have the two models, WACC and APV. First, let's look at the leverage ratio. We know that under WACC, the leverage ratio is constant, so the amount of debt is a constant proportion of the value of the firm. Under APV, the debt is an independent variable. Debt is determined by management and has no relationship whatsoever with the value of the firm. Having said this, then how do we determine the discount rate of the tax shield? The discount rate of the tax shield is a function of what? Well, in the case of APV, we know that the amount of debt is a managerial decision. So the amount of the tax shield, the tax savings coming from the debt, are only a function of the interest rate or the cost of the debt. Okay, so the higher the cost of the debt, the higher the tax savings. So it's the only variable determining the risk, the volatility of the tax shield is the cost of debt. So it makes sense to think that the discount rate of the tax shield in the case of APV is just the discount rate in this case is just the cost of debt. What happens in the case of WACC? In the case of WACC, the situation is much more complicated because in the case of WACC, it is true that the same as happens with APV, the higher the cost of debt, the higher the tax shield. But also, the tax shield, the amount of the tax shield depends on the amount of the debt, and the amount of the debt depends on the value of the firm, given that the amount of debt is a fixed ratio, is a fixed proportion of the value of the firm. So we see then that in this case, the discount rate associated with the tax shield, in the case of WACC, is not so clearly defined, because on the one hand, it depends on the cost of the debt, and on the other hand, it depends on the value of the firm and rho, the discount rate, which is associated with the value of the firm. So concluding, we know that the discount rate for the tax shield in the case of APV is clearly the discount rate of the debt. In the case of WACC, is not clearly determined. Let's come to a preliminary conclusion focusing on two extreme cases. Case 1. The level of debt is independent of the value of the firm and can be anticipated throughout the horizon. So this basic APV case in which the value of the debt is determined by management. So the only determinant of the tax shield is the only discount rate associated with the tax shield is the cost of the debt. So there is no doubt that APV in this case will be the preferred method to value the firm, okay? Because the tax shield is discounted at the cost of debt, as we explained before. The other extreme case is when the firm seeks to maintain a stable debt ratio. Well, this is precisely the assumption, the main assumption behind WACC. So it makes sense to think that in this case, the value of the firm should be computed using as a discount rate the WACC rate. And it has also been proved by Insoll and Kofod in their paper 1997 paper that when you use WACC to value a firm whose debt ratio is constant, then automatically the tax shield, the present value of the tax shield is calculated with the right discount rate, accounting both for the cost of debt and the risk associated with the value of the firm. So this complication that we explained before is also automatically solved when we use WACC. So in case 1, we use case 1 in which the debt is completely determined by management, we use APV. In case 2, the other extreme case in which the debt is a fixed proportion of the value of the firm, the right discount rate is WACC. Unfortunately, in practice, none of these cases are very realistic. In practice, the custom is to determine the debt policy of the firm in a mixed way. On the one hand, a minimum debt ratio is established that remains constant for the long term, meaning that there is a proportion of the value of the firm which is relatively small, like a debt ratio which is relatively small, but it's always kept at a constant ratio, so it's consistent with the WACC assumption. But there is also a second tier of debt, which is managerially determined. So the debt is partially, the first tier is determined by the value of the firm, and the second tier is determined by management. And the magnitude of each one of these two tiers depends on how volatile the environment is. For instance, in a very volatile emerging market, the managerial portion, the second tier, tends to be much more important than the first tier that depends on the value of the firm, and vice versa. In a very stable market, most of the debt is determined by the value of the firm. It's a fixed ratio, and only a small proportion of the debt is managerially determined. Hence, concluding, the debt is partially dependent on the value of the firm in practice and partially dependent on management. So, if this is what happens in real life, then WACC in principle is inappropriate because the value, the tax shield is not determined only by the value of the firm, but it's partially managerially determined. So we should try, in principle, to use APV. However, even if we try to use APV, we have a problem because the discount rate is not clearly defined in this case as well, because again, part of the risk comes from the value of the firm, regarding that first tier, which is a function of the value of the firm, and part of it depends on management. So we have a problem with what cannot be used. Okay, and APV is difficult to use because we still have the problem of the discount rate. Fortunately, we have the proposal by Professor Fernandez from IESE, which I believe solves this problem of the lack of definition of the discount rate. Fernandez says that the difficulty in selecting a correct discount rate for the tax shield comes from the fact that the value of the tax shield is actually not the discounted present value of one cash flow. What Fernandez says is that actually the tax shield comes from the difference of two cash flows. On the one hand, we have taxes that the unlevered firm will pay, and the other is taxes that the levered firm will pay. And the tax shield is just the difference. So what we should do is we estimate first which are the taxes that the unlevered firm will pay. We calculate the present value of these taxes. Second, we calculate the taxes of the levered firm. We calculate the present value of these taxes, and then the difference between these two will be the present value of the tax shield. So what remains is to determine which are the discount rates corresponding to these two tax cash flows. Well, let's first focus on the unlevered firm. The tax for the unlevered firm is calculated on profits. Profits, in this case, come from the full assets of the company because we don't have any debt. So the profits coming from the asset side go directly to the shareholders. So the discount rate is the discount rate consistent with the discount rate of the assets, rho, which in this case is equal to RE, is equal to the discount rate on equity because there is no debt. So the discount rate that applies to the unlevered taxes is rho, which again in this case is equal to RE because it's the discount rate that applies to the unlevered cash flows. And the discount rate that applies to the tax flows for the levered firm is the same reasoning. Okay, we have taxes are calculated on profits. Profits are associated with the discount rate of equity for the shareholders. Okay, in this case, RE is different from rho. Okay, so in this case, we discount the taxes coming from the levered firm at RE. So the problem is solved. Okay, we just calculate first taxes for the unlevered firm, and we discount those at rho. Second, we calculate taxes for the levered firm, and we discount those at RE. And then we find the difference of present values, and that will be the present value of the tax shield. Let's illustrate with an example. Imagine this firm. In this firm, we have first, this company has a corporate tax rate of 30%, a discount rate on equity RE of 20%, which we are assuming constant over the horizon, and an unlevered discount rate rho of 15%. We also have the profit and loss statements, okay, for these 3 years, years 1, 2, and 3. We have sales, cost of sales, operating earnings, depreciation, earnings before interest and taxes. Then we subtract interest, we get earnings before taxes. Then we subtract taxes and we get earnings after taxes. So let's use a Fernandez method to compute the present value of the tax shield. First, let's focus on levered taxes, so the taxes for the levered firm. Well, we know which are these cash flows. We already calculated them in the profit and loss statement. Okay, the cash flows in this case are 2550, 24, and 5250. So we copy these amounts up here, and we discount these levered taxes at the levered discount rate, meaning the discount rate of equity, RE, 20%. So we apply this discount rate, and we get a discounted cash flow, present value, of 6830. 6830 will be the present value of the levered taxes. Second, let's calculate the present value of unlevered taxes. Well, first, we just copy earnings before interest and taxes. We know that earnings before interest and taxes are 100, 100, and 200. And then we estimate unlevered taxes just by multiplying EBIT by the corporate tax rate of 30%. So we obtain the tax flow for the unlevered firm of will be 30, 30, and 60. Then we just calculate the present value of this cash flow using the unlevered discount rate, which is rho, in this case, 15%. And we obtain a present value of 8822. So the present value of the tax shield will be the difference between these two quantities, 8822 minus 6830, for a total of 1992. So we have solved our problem for the cash flows throughout the horizon, from time 0 to time n, okay, the years in which we project the cash flows. Basically, what we do is that we calculate the present value of these cash flows using adjusted present value. Okay. Now let's focus on the terminal value. Okay, so the amount of money, the value of the company at the end of the projection period. And we know that often, usually, this present value is represented as the present value. This terminal value is represented as the present value of a perpetuity. A perpetuity that obviously will assume a constant leverage ratio. And we saw before that WACC is the appropriate discount rate when we have a constant leverage ratio. So it is easy to conclude that WACC is the appropriate discount rate for the cash flows of the perpetuity that starts at the end of the horizon. So what is our conclusion here? The conclusion is that we should use APV, adjusted present value, for the cash flows within the horizon, and WACC for the cash flows after the horizon, whenever these cash flows are represented by growing perpetuity. Okay, so we calculate the present value of this growing perpetuity using WACC. And for the cash flows throughout the horizon, so for the period in which we are going to use APV, at what rate we will discount the tax shield? Well, it depends. If the debt is fully managerially determined, 100% managerially determined, so we know that the right discount rate for the tax shield is the cost of debt, RD. If this is not the case, if the debt is partially dependent on the value of the firm, which is the most common case, then we use Fernandez method, by which we calculate the present value of the tax shield as the difference between the present value of the taxes of the unlevered firm minus the taxes of the levered firm. And that is all that I wanted to share with you today.